All right, so today's lesson is factoring monomials, also known as greatest common factor. That's the way I introduced it last semester when we did this a little bit. Factoring you did last semester, and the next sections are kind of more factoring, so we'll see how that goes. All right, let's look at the first one, factor the expression completely. And what it means by monomial is from this polynomial, this binomial, there's one thing we can pull out that both share. So 10x and 5. What do they both share that we can divide out?
5.
Exactly. So if you pull out 5, what's left in the parentheses? 2x minus 1. And that's all we can pull out. So we pulled out a monomial, something that's just one piece. And then number 2 here, factor expression completely. We have a binomial. It could be trinomial or multinomial. But from each term, from this term and this term, as we have 2 here, what is that thing we can divide out? X, and it seems to be just one x. So what's left inside? Well, it's 8 stays the same, x squared minus 1. Because if we pulled out x from x, you're left with 1. If you divide x from x, you're left with 1. So another monomial. It's a one-piece thing. Notice it's not a number. There's simply no number we can pull out. All right, moving on. Factor the expression completely, the one up top. It's still a monomial we're putting out, but I think it's like a number and a variable this time. So what number can we pull out from 14 and 18? What do they both share that we can divide out? Probably just 2. Okay, and then also I think there's a variable we can pull out because there's an x cubed and x squared. So they can both afford to part with x cubed. So what's left? For the first term, 7's left. And do we take out all the x cubes? Yes. So it turns into 1. In other words, 7 times 1 is just 7. Yeah. Okay. And then the second term, we pulled out a 2, so we left with 6. And then when we divide out or pull out the x cubed from x fourth, just left with 1x. That's how that works. So still a monomial we pulled out. 2x cubed is a monomial, even though there's 2 numbers. Monomial because it's not separated by plus or minus. Yeah. Yeah, my bad. What did I do wrong? I divided the 2 from 18, should be 9. That's right. I don't know why I thought 6. All right, then the second one, factor the expression completely. We got 2 terms. What can we pull out from both? Looks like it's going to be a number as well as a variable. We could do the variable first. This time doesn't matter. I think we pull out an x cubed. Do you see that? No. The first one has 4 x's, second one has 3 x's. We can divide out x cubed. And then there's a number we can pull out. What can we divide out? What's the greatest number we can divide out from 24 and 42? It's 2, 4. I'm not so sure. So I use a calculator. 42 divided by 2 is 21. Let's just stick with 2 for now. But you know what's also nice? I would pull out the negative. So what's left inside is 12x plus 21. So here's something I got to double check before I finish this. Was there anything else we could pull out? Because looking at it right now, are we sure it's totally complete? Because looking at 12 and 21, it looks like I can divide out a 3.
What about you can divide 2x and 12 by 2?
divide those numbers by 2, but the 21 doesn't divide into 2. So 3 looks like something we can divide out. I don't know. What's the best way to... So factor out 3. So if you see what I did, I pulled out a 3, multiplied it with the 2, so I got negative 6, and that's what's left inside, and that is complete. Like inside the parentheses, there's nothing else I can factor out. So all I'm thinking is, initially, instead of just dividing out the negative 2, I could have divided out negative 6. Anyways, all right, and the last one, what can we divide out? I'll definitely divide out a negative. Looks like, and other than that, only another number. Negative 7. 30 doesn't divide into 7. Negative 3. 10, so we're left with 10 plus 7x. Yeah, I like that. Simple stuff, just gotta